So students, today we will discuss system of equations. Okay, system of equations. We'll discuss about the consistency and inconsistency of system of equations. So let me take some example. A1x plus b1y plus c1z is equal to d1. A2x plus b2y plus c2z is equal to d2. And a3x plus b3y plus c3z is equal to d3. See, basically these are three different planes. Three different, you can say equation of three different planes. We consider, if we consider 3D, three-dimensional geometry. But if we take it as a linear equation in x, y, z, then these are simply three different equations in x, y, z. Three different linear equations in x, y, z. Okay. Now, if somebody will ask you how to find x, how to find y, and how to find z, then there is a simple formula: delta x by delta is x, delta y by delta is y, and delta z by delta is z. Now, you might be wondering what is delta x, what is delta y, and what is delta z. So, here comes the use of determinant. There's a rule, Cramer's rule. Cramer's rule. And with the help of this Cramer's rule, we define delta x, delta y, and delta z in the form of determinant. Now, what is the rule? When you write delta, you just don't take in account these d1, d2, d3. You just take a1, b1, c1, a2, b2, c2, and a3, b3, c3 in the given order. Whatever order you are seeing, a1, b1, c1, in the same order you write a determinant. This is delta. Okay. Now, what about delta x? When you write delta x, then we need to cover up this part. We are not going to take A1, A2, A3. And in this order, first D1, then B1, then C1, you can again see the order. First D1, then B1, then C1. This order. We will write delta x. So we will not take the x part, A1, A2, A3, and we will write D1, B1, C1, D2, B2, C2, D3, B3, C3. Okay, and the determinant. Now, what about delta y? For delta y, there is slight change as this is the middle column and we need to put a minus sign. So if you don't want to multiply the determinant with minus sign, then you follow the same order. You just don't take this column, B1, B2, B3. So according to this direction, it should be D1, A1, C1, D1, A1, C1, D2, A2, C2, D3, A3, C3. But I will write D1, C1, A1, D1, D2, C2, A2, and D3, C3, A3. Because the middle one is of negative sign. There is a rule of minus 1 to the power I plus j. I will discuss later why this delta y is negative. Because if you follow this direction, then it should become D1, A1, C1, but it is D1, C1, A1 because we know that delta y is having negative sign. Now again for delta z, we will not take this column C1, C2, C3 and we will write in the same direction D1, A1, B1, D2, A2, B2, D3, A3, B3. Okay. Now, here we have completed delta, delta x, delta y, delta z. So what is x? According to Cramer's rule, This x is delta x by delta, as I've written, y is delta y by delta, and z is delta z by delta. So using these three or four determinants, you can find x, y, z involved in these three equations. Okay. But ultimately, if you want to visualize it, these are three different planes in 3D. This is the first plane. This is the second plane. And this is the third plane. So later on, when I will discuss about the consistency and inconsistency of the system of equations, then you might be needing the visualization through planes. So let me tell you what is the meaning of consistency and inconsistency. See, let me write the equations again. A1x plus b1y plus c1z is equal to d1. A2x plus b2y plus c2z is equal to d2. And A3x plus B3y plus C3z is equal to D3. These are the system of equations. Three linear equation in XYZ. Okay. Three different planes. Now, meaning of the word consistency. Meaning of the word consistent system of equations. Meaning of this particular word is like these three equations will have some solutions. Consistent means these three equations will have equations will have some solution. Now, what is the meaning of some solution? Unique solution or infinite solution? Unique solution or infinite solutions. What is the meaning of inconsistent system of equations? Inconsistent means inconsistent system of equations means no solution. No solution to these system of equations. Okay. Now, how to correlate, how to find the condition that a system of equation is consistent or not. Now, we have already gone through the formula like x is delta x by delta Cramer rule, y is delta y by delta, z is delta z by delta. This is the invention by the mathematician Cramer. But see, it is not necessarily like we can only find x, y, z using this. You can eliminate z from 1 and 2, 1, 2, and 3. Like you can have the same coefficient of z in 1, 2, 3 by multiplying some constant. Both the sides are RHS and LHS. And you can remove z. And then you can have two linear equations in x and y. And you can find easily x and y. And then you can put it in any of the equations to find z. That is also a rule. But if you follow this is a very simple, kind of thing to understand consistency. Now, consistency means we have got some solution. No, the condition for this will be for consistency, the denominator should not be 0. Delta should not be equal to 0. Also, for unique solution, delta not equal to 0 and at least one of delta x, delta y, delta z not equal to 0. See, if delta not equal to 0, but your all numerators delta x, delta y, delta z are 0 at the same time, then you will get x, y, z all equal to 0. And that is not a unique solution. kind of unique solution, you can say. Because if your xyz is 0, then this d1, d2, d3 ultimately will become 0. So I am not interested in that solution. The unique solution means xyz not 0 at the same time. And one more thing you should note, like 0, 0, 0 solution is called uh, solution should be taken as trivial solution. And if somebody will ask you what is the meaning of non-trivial solution, then non-trivial solution here in this case means solutions other than 0, 0, 0. So I'm talking about this other than 0, 0 unique solution, and for this other than 0, 0, 0 unique solution, delta not equal to 0, and at least one of delta x, delta y, delta z not equal to 0. Now come to the second point. For infinite solutions. So for infinite solutions, delta equal to 0, delta x equal to 0, delta y equal to 0, delta z equal to 0. Now x, y, z all are in the form of 0 by 0. And in this case, you must remember that either you will get infinite solution or no solution. So for third point, for no solution also delta equal to 0, delta x equal to 0, delta y equal to 0, and delta z equal to 0 might be a situation. But see, this 0 by 0 form is ambiguous form. Here we can get both the possibilities, either no solution or infinite solution. So either no solution or infinite solution. Okay. Now coming to the fourth point, sure short no solution. Surely no solution. For this, let me tell you, if delta equal to 0, but at least one of delta x, delta y, delta z not equal to 0, then we must have no solutions. See, these are the technical things. You understand that denominator cannot be 0. And if denominator is 0 and numerator is also 0, then we have both the possibilities, either no solution or infinite solution. And in a unique solution, since denominator is not 0 and numerator is also might be 0 or not 0, then ultimately we are getting some solution other than 0, 0, 0. And in fourth case, if the denominator is 0 and numerator is, you say, not equal to 0, situation like 2 by 0, 3 by 0, we understand that we don't have any solution. But these are the mathematical way of expressing it. If you go by 3D planes, then this is very simple, believe me. Let me tell you just one thing, like for these two to distinguish, if I draw a plane like this is a plane, this is another plane, and suppose I take a bisector plane, black one. Black one is the bisector plane. This red one is plane 2, blue one is plane 1, and this black one is bisector plane. Can you visualize one thing? This line is the intersection of all three planes. This line is intersection of all three planes. So in this case, this line will contain infinite points which satisfy all the three planes. So it will have infinite solutions. So if you want to visualize infinite solutions, you can take two planes and one bisector plane. Okay. So two plane, you can take any two plane, a1x plus b1y plus c1z plus d1 equal to 0. The second one, a2x plus b2y plus c2z plus d2 equal to 0. And bisector plane, you know, plus c1z plus d1 divided by under root a1 square plus b1 square plus c1 square is equal to plus minus. Now from this, you can take one of the plane. And when you make determinant out of them, like delta, delta x, delta y, delta z, then you will get this solution. Delta 0, delta x 0, delta y 0, delta z 0, but you will get infinite solutions, not no solutions. Here you will get infinite solutions. Now what about this part? Again, we are getting all the things same. Delta 0, delta x 0, delta y 0, delta z 0, but no solution. So how to visualize this solution? This situation? This is very simple. You take three parallel planes. Plane number 1, plane number 2, and suppose there is a plane number 3. Now three parallel planes, nothing common in between them, will give you no solution. So three parallel planes will give us no solutions. So I hope this video is interesting for you, and I have left two things. Number 1 for unique solution, and number 4 for no solutions for you to visualize. Now you take the example of three planes in 3D and you try to find unique solution and other case of no solution. One case of no solution I've already discussed, three parallel planes. Okay. In this case, you will get delta x 0, delta y 0, delta z 0, delta 0. Okay. So this is something I have discussed, and now you can visualize number 1 and number 4 situation. Okay. So I hope this video is beneficial for you. Okay, go through it and get the advantage. Thank you.